There's a revolution happening right now, but you're not going to see it on the news. It's happening inside of us, inside our very own cells. Today, we're talking about how artificial intelligence is starting to understand, predict, and even enhance our biology. So let's kick things off with a pretty wild idea. What if an AI could look at a scan of you today, a scan that looks totally normal, and tell you about an illness you might get years down the road, long before any doctor could see a thing? Sounds like something out of a movie, right? Well, it's actually starting to happen. Okay, so to really get how this is even possible, we need to zoom way in. I'm talking down to the microscopic level, to the tiny, tiny machinery that basically runs the whole show. So pretty much everything happening in your body right now, fighting off a cold, thinking a thought, that's all run by these little biological machines called proteins. And here's the kicker. What a protein does is all about its shape, its 3D structure. For like half a century, figuring out that shape was one of the biggest problems in biology. It was like trying to take a super long, tangled piece of yarn and fold it into one single, perfect, unique shape out of billions and billions of possibilities. A total nightmare. So how did we finally crack this 50-year-old problem? It wasn't just a bigger computer or throwing more scientists at it. Nope. The breakthrough came from an AI called AlphaFold. It basically taught itself the rules of biology and physics and just solved it. And when I say solved it, I mean it. Look at this number. We're talking about 200 million protein structures. That's pretty much every single one we know about. And the best part? They put it all into a public database. So now, scientists everywhere can use it to kickstart the search for new medicines. It's a total game changer. Okay, so AI can figure out the fundamental building blocks of life. That's huge. But what do you do with that power? Well, the next step is to get personal. It's about seeing threats that have always been, invisible. And this is where that sci-fi idea we started with becomes very, very real. Let me introduce you to Sibyl. It's an AI model built by researchers at MIT, and it was designed to do one thing: predict lung cancer, one of the deadliest forms, years before it's even a thing. So let's break down the difference because it's really important. A human expert, a radiologist, they look at a scan for a tumor that they can see, something that's there right now. But Sibyl, it looks at the exact same scan, one that looks totally clean to the human eye, and it finds these super subtle patterns, things we can't see, that point to a high risk of cancer in the future. It's not just seeing the present. It's like it's reading the future of your biology. All right, so AI can see into the future of our health. Pretty incredible. But what can it do for us right here, right now? How about restoring and even enhancing our own bodies? This is where things get really personal. Think about a prosthetic limb, but don't think of it as just a tool. Imagine it as a part of you, something that learns how you move, what you intend to do, and just gets better and more natural over time. And here's the amazing part. It's pretty straightforward. You just think about moving your hands. That's it. Sensors pick up the tiny little muscle signals that your brain sends out, and then the AI acts like a translator, turning that thought into a smooth, real movement. It's this feedback loop that's always learning, always getting better. And it doesn't stop with limbs. We're pushing this partnership even further, right to the source, the brain itself. We're talking about brain-computer interfaces, or BCIs. With these, the AI doesn't even need the muscle signals anymore. It can translate your thoughts directly into action, letting people control a computer or robotic arm just by thinking about it. The lines are really starting to blur. Okay, these individual stories are just mind-blowing, but let's pull back for a second. Let's zoom out and look at the big picture. How could all this stuff change medicine for everybody? Making a new drug takes forever and costs a fortune. So many ideas just don't pan out. Well, AI is totally changing that game. It can run simulations of millions of potential drugs, see how they'd work against a disease, and pick out the best bets. And it does it in a tiny fraction of the time and for way less money. And what does that mean for us? It means medicine could get a whole lot cheaper and way more accessible. We're talking about getting life-saving drugs developed faster and getting them to everyone, not just the people who can afford a huge price tag. That's the real promise here. So we've seen all this incredible, world-changing potential. It's amazing. But we have to be realistic. We have to pump the brakes for a second and ask a really important question. What's the hidden cost of all this progress? And here's the catch. All these powerful AI systems, they run in these massive data centers. And those data centers are thirsty. They use a shocking amount of energy and water just to keep cool. People are starting to call them AI factories, and they have a serious and growing impact on the environment. So that's the question we want to leave you with. As we race ahead, using AI to unlock all the secrets of our bodies and build this healthier future, we also have to face the price of that knowledge. The real challenge isn't just about inventing the next cool thing. It's about doing it in a way that doesn't wreck the planet. So, can we cure ourselves without harming our world?